Hello everyone, welcome to this video, and this is another part of Active Directory Certificate Attack Series, or ADCS. In this video, we'll look into ESC14, as we can see on my screen in this brilliant blog by SpecterOps, which can also be using the altSecurityIdentities attribute that can be configured for explicit mapping. But if it doesn't make sense to you right now, don't worry. Let's first cover what altSecurityIdentities attribute is and how it's used basically for certificate mapping. So I'll refer to the SpecterOps blog, which is goes into the whole details and explains how all this works, and I'll link it in the description below. So here it explains that by most abusers we relied on implicit certificate mapping. So basically, EC1411 it was implicit, so it's mapping that uses UPN, DNS, or SID since latest updates, essentially comparing those attributes to the user's attributes to make sure this is the user, there's no impersonation. And if one fails, to try the other one. But with explicit certificate mapping, or when we're using the altSecurity attribute is set, it will look to make sure that it maps certificates based on that attribute, and if there's no match, it will just fail in most scenarios. So we can also see this table that talks about the different mappings. Some of them are weak, some of them are strong and more secure. Blocked also talks about different ways to abuse those. So if we scroll down here, there's lots of information. We won't go through all of it. So there are different scenarios, ECA through D. So we'll just cover ECA here. I was also trying to replicate it. So they're covering it from Windows using their certify tool. And that's what we will do in this video, because I was trying to replicate, I found a few blog posts how to do it from Windows. Oh, sorry, not from Windows, from Linux, using certify. But for some reason, it just keeps failing for me. I'm getting this error like non-stop. And I tried like different tool and everything. Just there's something about the way it requests a certificate that is just not working. Like it just keeps giving name mismatch. So it's not using explicit certificate mapping. It keeps using implicit one, from what I understood. Like I've been troubleshooting it for like a couple of hours. So we'll just do it from Windows, and if you know how to fix this from Linux, something's going on, I'll look into it again. But yeah, nothing so far. If you know something how to fix this error from Linux, please let me know, because I am really not sure, because I've tried it all. So yeah, let's dive into the lab environment. So as always, I got my Kali VM, which we will not use too much in this video because I'll do it from Windows. We got our domain controller, and we got our ADCS server. And we follow SpecterOps blog. Essentially what it says is that you need to be able to modify someone's altSecurity identities attribute. That's a mouthful. So essentially here I have my user fcastle, which is easier to open, show it in AD. Users and computers. So I got our regular user fcastle, and there's also an admin account for this. So we're this regular user, but there's been a misconfiguration where this regular user, for example, admin set up that regular user can modify that attribute for the admin account. And that's what we're gonna take advantage of. Basically, regular user fcastle can modify altSecurityIdentities attribute for fcastle admin, and that's how we're gonna perform the attack. If you ask me how realistic it is that somebody would allow write access to that attribute, I'd probably say very unlikely. And if you'd probably see something like generic all or write all permissions, and in that case you don't need to abuse EC14. You can just do shadow credential for the most part. But we'll just go through it because it's the series and it's interesting to see how it goes. So first I'll just use DACL edit to show you that we have the ACL. So Acolyte is a tool from Impacket that allows you to enumerate ACLs. So here we just give it the main controller or target, which is the main admin, and principal fcastle is basically, hey, what permission does this user have over this user? That's how it works. And not permissions, access control letters. And specify domain and username and password. So here we go. That doesn't matter. So we can see that fcastle can write altSecurityIdentities attribute on fcastle admin, and that's essentially what we need to do the attack, because we need to modify it. Alright, from here on, let's jump onto our Windows system. So, and we'll just follow the block. Here we're kind of like an admin already, but you can also add a computer. Again, like this blocks explain it really well if you wanna Google code part 14, where he looks into ESC14A, or this article from Hacker News, I believe it is. Oh, Hacker Articles. It explains how it can be done from Linux by adding a computer account. I really don't know why I couldn't get to work, and I'll continue looking at it. So, but yeah, we'll just follow SpecterOps blogs for this video because it worked for me. So first thing first, as always, we'll just request a certificate for the machine account because it matches all the prerequisites. It has client authentication. What are the prerequisites? I already forgot, so I've been talking too much. So yeah, these are the prerequisites. That's on the one, ACA. So essentially we need to have some kind of right property over altSecurityIdentities. We do have that. This is default. We are using computer account, so that's not an issue. And the requirements for one of the two authentication protocols are met. PKININ, there are no requirements, so it just has to exist, which it does. And by default in most ADCS environment it does. And S-channel configured, I just stated this, which is default, so not to worry. So essentially what we need for the most part is just be able to write property, and we need a computer account to execute this ESC14 scenario A. And the steps are as follows. So basically enroll certificate using the machine account, and we're gonna modify the altSecurityIdentities attribute on the target principal. We wanna impersonate that we have some kind of write permissions over. In our scenario is fcastle has permission over fcastle admin to modify this attribute, so we'll do that. And then we just authenticate using the certificate and specifying the target principal wanna authenticate as. That might be a little bit too much, but let's just go through that. I can hopefully it will make more sense. Let's make sure my DC is still up, and it is. So first, I already transferred all the tools we need. We need those partial scripts that the author wrote, basically to set the attribute. We need turbos and we need certified. Let me remove the cert files already created. Here we don't need that. Oh, I just removed certified. Oh my god. 1 second, I'll pull it again. No, it doesn't. Is it here? Yep. I just need to transfer certified real quick. Sure, this will work. Let's just modify it. Alright, we're good now. Alright, so first, as article mentions, we just request certificate as a machine account. So here we're an admin, so we're gonna impersonate this computer that we're on. Let's find a CA. in my case. You also need to give it server name and then the CA name. And you can find the CA name multiple ways. If you wanna know how, just check out my previous videos, and I show you how to use certify find command, and it gives you the CA name. Same with the template. But here we already know the template because that's what article says. We just need the machine template. Place machine and great, certificate has been issued, great. So now we just have to use certitl to get PFX. It's also next step in the article. So yeah, we'll just do dash merge PFX. What do you say it does? Oh, we need to k the file. So cert.pem, and we get the certificate. I'm also using an older version of certify. I think 2.0 does it by default, so you wouldn't have to do that. I just don't have it on this machine. Right, and we need to save the key as well, so the key would be this part. And now with the certitl, merge pfx, and we give it .pem file, and what we want to save it as pfx, and I give it empty password because it doesn't matter. Now we got the pfx, and now we want to dump the serial number, so that displays it here. That's basically what we will set for altSecurityIdentities attribute to ensure strong certificate mapping, so we could impersonate the user. So let's do that. Dump and our cert.pfx. Give it an empty password. And here we can see the serial number. So this is what we need. So open Notepad real quick so we could save it. And we also are going to need the share. Alright, so now we need this PowerShell scripts. You can just download those from the GitHub. So first we need to create a serial number to set for the attribute, because it has to be in a specific format. Do that. So we give it the serial number right here, and I think it's distinguished name. Oh, it's a shared distinguished name. And this has to be in a format like this. So let's see, domain and TLDR. I think it's TLDR still, even in the domain environment. So now it's just gonna give us the format we need to set for the altSecurityIdentity attribute. So just press yes. And now this is the string we need to set on fcastleadmin. Essentially, once we set it, the moment we authenticate to the certificate, it's gonna use this attribute to match who can authenticate using the certificate. And because FrankCastleAdmin will have this attribute, we'll be able to authenticate because of the explicit mapping using this attribute. And for this, we'll use this command. And you just have to import modules already. I just did that already. Just do ./add, and this will import it. So here we give it the mapping that we just created and distinguish it. Oh, it just became too much. This string. And we need to give it the distinguished name. I can just take it from. Oh no, the distinguished name is gonna be. Oh, what just happened? Oh, I froze for a second. Oh, my DC died. Oh, let me power it down real quick. We're doing that. Distinguished name you can get from a domain controller, or just do it using bloody ID, I think. So should have it somewhere here. Yeah, I'll just take it from bloody ID get object. Copy. And let's wait for the DC to boot back up so we could set it. Because we do set it on the domain controller. Yeah, once we set, we'll just need to confirm it that's set. And then we can get a TGT using Rubius and while impersonating Frank Castle admin. Back up. Alright, that should be good enough. Alright, let's run the command. Alright, now we are gonna use blood AD to verify that this is set to this. So it's 6E zeros and ends in 3B. Go ahead and have the command, yep. So blood AD is just, oh, it's set to multiple. Not sure if this could be a problem. Let's do it again. Let's clear it with blood AD. And set it again, just in case. Guess I could have tried that, but don't want to throw in the video. Alright, so yeah, now we can see 6E and ends in 3B. So now this attribute, whoever has this attribute can authenticate using the certificate requested previously using the machine because that certificate has the serial number. So now let's do Rubius, do impersonate fcastle admin. And the command would look like this, ask TGP. So asking for a ticket or any ticket. So we could use Kerber's authentication. Specify user, it's going to be fcastle admin because it now has this attribute set. Specify certificate, which is going to be cert.pfx that we created. And I'll also do no and ptt to pass the ticket. So it's in memory. And look at that, we got it. And if we do klist, we got the certificate for fcastle admin. So now whatever permission that admin user has, we also have it now. Which is great. We also can take this ticket and convert it using ticket converter and use it from Linux if we want to do other things. So yeah, as I said, if you know how to fix this error from Linux, because I was following this guide step by step, trying to understand what's going on, I compared certificates like everywhere, and I didn't see any weirdness. Guess I'd have to like go through the code for certify to see how it requests certs versus certify on Windows, but it's probably gonna take a lot of time, and I do at some point, but not right now. So yeah, let's talk about mitigations. I think if we go to Luke's page on ESC14, it explains it really well. So essentially, disable weak mapping. If we go back to certify block, they talk about it. Subject name email are very weak, and you should disable those. But I think from 2024, Microsoft released a patch where these are disabled or not used by default anymore, so don't really have to worry about that too much. Next one is because we're able to write that attribute on another user, we have to edit our ACLs, basically access control entries, to make sure nobody can unintentionally write those attributes or just do a generic edit. In general, it's great to edit the ACLs using Bloodhound or PowerView to make sure there aren't any misconfigurations. And last one is set enforce strong certificate binding on DCs to 2, which is full enforcement mode. Essentially what it does mapping always based on seeds or strong mappings, and it's gonna ignore if you set some kind of weak mapping or specify an alternative VPN, it's just gonna ignore it. So yeah, that would be it for this video. Hope you enjoyed it. We got just a couple of ESCs left, so we'll cover ESC14 and ESC16 in the future videos. I'll try to do it from both Linux and Windows in the future, because as you can see, it's interesting how one worked from Windows but didn't work from Linux. And I just want to make sure we cover the full gun for the last two, and then we'll start working on something else. Alright, thank you for watching. I'll see you next one. Bye.